Welcome to the Mission Strong podcast, where we share real stories from the field, practical public safety knowledge, and a behind-the-scenes look at the Boise Fire Department.
Today on Mission Strong, we're going to talk about a high-angle rescue that occurred in downtown Boise. This will be the first episode in a 4-part series discussing our transformation into a modern all-hazards fire service. Historically, fire departments were exclusively focused on fire. Our organizations now are often referred to as all-hazards departments because of the wide range of emergencies fire departments are equipped to address. I'm the Boise Fire Chief, Aaron Hummel, and I'll be walking you through this episode, introducing the members involved and providing some context and background to the story of Boise Fire Department's technical rescue team. Thanks for listening and enjoy the show. For over 100 years, Boise Fire, like most city fire departments in America, almost exclusively focused on preventing and fighting fires. For most departments, this began to change after the Vietnam War. That conflict resulted in the deaths of more than 58,000 U.S. soldiers. It was also one of the first major conflicts that mastered the practice of providing rapid trauma medicine through the use of medevac helicopters in the field. And it was responsible for saving thousands of lives that would have otherwise been lost. As a result, following the war, the U.S. Congress passed the Emergency Medical Services System Act in 1973. This act established national funding and standards to develop regional EMS systems across the United States. The logic was simple. Fire departments were staffed with firefighters used to responding to and dealing with fire tragedies, which often included injured people. Additionally, fire stations were strategically located throughout communities for quick responses to fires. Therefore, EMS was a natural fit within fire departments to provide a rapid and professional response. This same logic has been applied for responses to everything from vehicle extrications to technical rescues to hazardous materials emergencies. In Episode 1, we are going to focus on Boise Fire's technical rescue team. In Episodes 2, 3, and 4, we will talk about EMS, water rescue, and the hazardous materials team. In each episode, we will feature a real-life rescue where Boise firefighters saved lives using these additional skills. So let's get started, and we'll talk about a rescue that happened nearly 2 decades ago.
It just so happened that out of the folks who showed up, I was one of the few who had been through all of the training, and so I was therefore the person chosen to go over the edge.
On the afternoon of March 15, 2006, a construction worker was working on one of the outer walls of a downtown Boise hotel when his basket fell out from under him, leaving him dangling from his safety harness, which caught him almost immediately. Retired Fire Captain Jim Walker was on the technical rescue team at the time and responded to the call.
He was hanging in his OSHA harness, which, by the way he was wearing it, he never planned on having to use it. So it cut off the circulation to his legs. He was in misery. He only spoke Spanish. So I was trying to calm him. I don't speak Spanish, but he was fairly panicky. He was ready to be out of that harness.
Multiple companies responded to the call, including the department's 3-year-old technical rescue team.
Truck 1 responded and they knew that building. They'd laddered it before and determined that it was beyond their reach. And we actually decided not to do a rappel. We were going to do a lower. They thought there might be a little bit more control. There was the risk of me rappelling past the victim and then not having the leverage to pick him up onto my system, de-weight his system, and put his weight onto mine. We set up an anchor system. Steve Rizzullo was a battalion chief. He was one of the founders of the team, and he was overseeing the anchor building. We had Rick Payne was in training. He was a safety officer, and he was in place as the edge man, so he was relaying my communication to the lower team. As it happens, there was a little bit of a delay. I mean, things went wrong, but we still made it look good. I went over, and the team likes to, at the time, would give me grief because I came over, and there's a lot of jokes about the size of my head. They said it was like an eclipse coming over the edge of the building. I blocked out the sun. And then when I came over, my size 13 made a huge dent in the stucco, which is still there today. So they lowered me slowly, and when I yelled stop, went to Rick Payne. By the time it got to the lower team, they had lowered me just a few inches too far, so I didn't have enough pull to unweight his system. So then they had to vector the rope to get the extra length we needed to unweight his system. But that was all stuff you couldn't see from the ground. So.
Let's pause here for a moment. For those in the fire service, part of what makes this career special is the family you inherit. That is assuming you make it through the training. There's a lot of banter and good-natured chop busting that helps build our bond. And it's pretty much a universal law in the fire service around the world that if there's an opportunity to tease another firefighter, it's going to happen. Walker, a former Boise State University offensive lineman, was a big man. Rumor had it that Jim Walker apparently had the largest head on the entire Boise State football team and had to have a custom helmet made for him. Hence the reference to the solar eclipse effect. All right, back to the rescue. Not only was the crew performing a high-angle, high-risk rescue, they also had a crowd gathering on the busy streets below. And it turned out the audience was much bigger than that. A camera mounted on top of a nearby building had started live feeding the incident, and that video was soon picked up by CNN. People across the country were now watching as Walker was carefully lowered towards the construction worker, who was clearly in distress. Within moments, Walker secured the worker into his rope system, and the two were slowly lowered down into Truck 1's tower ladder bucket waiting below.
So yeah, we got him in, helped strip him of his OSHA harness, and obviously his legs were weak, and there was a couple of the Truck 1 personnel who helped stabilize him in the bucket while we lowered him. I actually got off in the bucket as well. I didn't have them lower me all the way to the ground.
In every incident, even those with the best outcomes, there's an opportunity for hindsight and a chance to look back and say, what could I or we have done better? This incident was no different.
I think if we had to do it over again, we would have opted for rappel rather than lower. I think there is a sense of pride that I joined this team for a purpose, and then I actually got to use the skills to impact someone's life. That's pretty cool.
Well, there you go. You don't have to have the experience of a rescue like the one Walker and Boise Fire's technical rescue team faced to learn something from it. In this case, communication delays between Walker and the crew controlling his descent from the roof caused him to be lowered a little too far. Normally in a high-angle rescue from above, the rescuer stops just above the victim. From there, the rescuer places a fire department harness on the victim that is connected to the rescuer's rope system by what is known as a pick-off strap. Once the harness is secured on the victim, the rescuer unweights the victim by pulling up on the pick-off strap. Being slightly above the victim gives the rescuer the leverage advantage of pulling from above. This action fully transfers the victim's weight onto the rescuer's rope system and creates slack in the victim's OSHA fall protection line so it can be removed. But in this case, Walker had been lowered to the same level as the victim. That meant he did not have the leverage advantage of being above. So the team adapted. Quick-thinking members on the roof kept Walker's rope from sliding along the parapet wall, while other firefighters began pulling the rope sideways in a technique known as vectoring. This was to raise Walker just enough, only a couple feet, to give him the leverage he needed to complete the pickoff. It might seem like a good idea to set up a lowering system so your rescuer can be hands-free instead of having to rappel, but the communication delays that come with lowering, calling for a stop, and the rack operator reacting can make precise positioning tricky. It is usually better in a high-angle rescue situation to have your rescuer rappel so they can control their own descent. Now you might think a fire department just puts out fires, and we do put out fires. But Boise Fire Department is an all-hazards department. That means we're prepared for just about anything. Fires, floods, car accidents, extrications, natural disasters, water rescues, plane crashes, hazardous material spills, the list could go on. But it wasn't always this way. Before the technical rescue teams were established across America's cities, untrained police officers, construction workers, military veterans, and savvy civilians did what they could to help. One person who clearly remembers the days before we had all hazardous departments is Paul Anderson.
Well, it was putting together things by, like you had a scissors and paper, and you were, where do we get somebody? We got a hazmat spill. It was like nobody knew what to do. It just didn't have. Now there are regional hazmat teams that respond. The fire department has rescue extrication for auto accidents. They have tech rescue teams for either high rescues or the trench rescues and so forth. It's much better. It's like, it's an enlightened time compared to, it was the dark ages back before that.
Now retired, Paul's career began in 1957 as a firefighter in North Dakota, an ambulance attendant in Minnesota, and eventually he became Idaho's first EMS bureau chief from 1973 to 1992. It was Paul who helped change the way we respond to emergencies.
I went on a call. The first week I was chief of EMS, it was July of '73. I went into Idaho Ambulance just to shake their hands and say, I'm Paul Anderson, the new EMS chief. Glad to meet you. When they got a call, it was a bad auto accident, Chinden and Eagle. That was a rural intersection, not even a traffic light then. I could be wrong about the traffic light. There might have been a traffic light there. But there was a lady, she was probably 60 or 70, who was trapped in the vehicle. And you didn't call the fire department for extrication equipment at that time because they weren't doing extrication. They didn't have extrication gear. So one of the Idaho ambulance people got on the radio and called the headquarters, send so-and-so out with the pickup truck. We've got an extrication. The pickup truck had two items, a come along that would change, you used to pull a steering wheel forward to get somebody out, and a hydraulic ram that you could push up a dashboard, for example. It turned out to be just what we needed, but they didn't have any cutting devices like they would use if they had to cut the posts on a car to get the roof off, we'll say. We got the lady out. It wasn't ideal because they didn't have the whole assortment of extrication gear. And they had a minimal amount of cribbing, not what they carry now. I mean, it was making do with what was available. And if that was the best extrication equipment available in this valley at that time, how would they have handled a semi-truck extrication incident? They weren't equipped to do it.
Paul was a pioneer and a change maker in the world of EMS and all hazards, writing papers on best practices that have influenced communities not only in the US, but around the world. Still, it wasn't until 2003 that the Boise Fire Department Technical Rescue Team was established, and even then, it wasn't exactly official.
You know, there were some outstanding jokes that the tech team is just a club. It's for a special team for people who can't swim and can't figure out chemistry.
One original member of the Special Operations Team and founding member of the Boise Technical Rescue Team was Mike Walker, who just so happens to be the younger brother of our rescuer, Jim Walker. He might also have been our informant that talked about the size of Jim's head in the football helmet. Before we hear from Mike, let's find out about what Big Brother Jim has to say about him.
He was probably one of our best rope instructors we ever had. He's just a nerd, and you know, he was a physics major in college, and a lot of the mechanical advantage that we use for systems really interested him.
For Mike, the early days of the Tech Rescue Team weren't far off from a guy traveling in the West in a VW van with a bunch of rope and climbing gear in the back.
It was referred to as the Tech Rescue Club because we had the dive team and the hazmat team and the ARV team, and they were all identified as specialty teams. And then here comes these rope guys that want to be a part of it, and we're training, and we're a specialty team. Well, no, you're not. You're not identified as a team officially. You don't get paid, and we're not really convinced you guys know what you're doing. So it took some time 9/11 did make a difference, and we got all the equipment with that grant funding. And then we started doing a lot of training. The department identified us as a actual legitimate official team. That changed things a little bit for us. And then we started responding to calls. So it was a process. It was a transition. I mean, it started from one person who had rope equipment in the back of his department truck to 30 people that are trained to technician level over the course of about 10 to 15 years.
So the Tech Rescue Club became an official team, and since then they've been an integral part of saving lives in the Treasure Valley.
So we have 5 disciplines that we train our folks to, per the standard, to technician level. So there's rope rescue, which is sort of the foundational skill. The standards require that you have rope rescue as a base foundation. But from there, we have confined space rescue. So, think like vaults, like manholes, things like that. There's a lot of facilities. Micron has several thousand confined spaces, and they can be very dangerous. So that's the second discipline. We have trench rescue, which we've had a number of calls for trench rescue over the years. Not near as many as you would expect with all the construction going on, but it is a huge potential that we think about all the time. Structural collapse, we prepare for the worst case scenario. So like a large building collapsing and having to short up and pull people out. But that's actually a fairly common one too. We get vehicles into buildings all the time, and our team will go out and shore up the building to make sure it's stable so they can pull the car out, and an engineer can come in and assess it for what needs to be done. And then the last one is the machinery entrapment.
In 2024, a major structural collapse of an airport hangar under construction again captured national headlines. The collapse killed 3 people and injured 9 others. Surviving workers had to be rescued from the wreckage within an unstable structure. In 2025, a worker fell 20 feet down a narrow vertical pipe and had to be rescued using a crane from above. In 2021, a worker was trapped inside an excavator and suffered serious injuries. These incidents happen, and when they do, it's usually the fire department that comes to the rescue.
You have to be able to rappel from high elevation to low. You don't have to be able to go down. You have to be able to go up. You have to be able to package people into a litter basket. You have to be able to raise them, lower them. And so our goal is to train everyone to one standard that we know that they can meet the standard. And if we're out on a rescue, I can turn to someone and say, hey, I need you to set up this anchor system. And they can set up that anchor system.
Like everything, it's a work in progress. We're always trying to make things better. And that brings us to what it takes to be on the team. And it's not just one thing.
Well, I think it helps to have some mechanical aptitude, for sure. Not having a fear of heights. Or claustrophobia for confined spaces. Generally people that have also, when we talk about like trench rescue and structural collapse rescue, having a construction background is really handy. Just being able to use tools, and I've seen this where we start building something, a certain like shoring system, whatever, and watching someone use a hammer, you can tell I can tell you've never done this type of work before. And then there's other people that just they pick it up and they're like virtuosos with a hammer.
Captain Brent Matthews has been on the technical rescue team since the start. For him, there's just something about being the last resort in an emergency.
I would say the scariest part about it is kind of the aspect of there's no one left to call after us, right? Like a cop gets on scene and he can't solve a problem, he's gonna call fire. The engine gets on scene, they can't solve the problem, they're gonna call the truck. And when the truck gets on scene, they can't solve it, they're gonna call us. There's no one after us. And there's something that's scary, but also really kind of cool.
For folks who don't work in fire, being the last resort might sound like a nightmare, but Captain Matthews draws to the adrenaline rush of pressurized problem solving. That started long before his membership on the Boise Fire Department Technical Rescue Team.
I've always loved the all-hazard aspects of the fire service. When I was getting my fire science degree a long time ago, I was lucky enough to take a couple cave rescue classes and high-angle rope rescue classes, and it's always really spoke to me. And for a short time before coming to Boise, I worked for Salt Lake, and they actually have a FEMA USAR Task Force 1 out of Salt Lake. So I worked with a lot of guys that were on the team. I was able to go to a lot of the trainings with them. And once I saw the collapse and the trench rescues, all the different aspects of technical rescue, I was just in love with it. I mean, the fire service in general is just us pretty much problem solving, right? But that gets compounded when you have a technical rescue call. It really, I think that's what draws me most to it, is it's just problem solving, and sometimes very complex problems.
Research suggests that when we solve a puzzle, our brains release dopamine, the so-called feel-good neurotransmitter. Even something as small as a crossword can give your brain a hit of happiness and motivation to tackle the next challenge. For the firefighters on the tech rescue team, that's what it's all about. It feels amazing to be the go-to rescuers that solves a problem others couldn't solve.
Some of the most memorable calls I've been on were ones that you're trying to problem solve and nothing's working, and the stuff that has worked 100 times before on similar calls, nothing's working. That gets really both emotionally wrought and really stresses physical. I just love being stretched sometimes, and my guys I work with always say I love chaos, and I've always been drawn to chaos. So I like going into a chaotic scene and trying to pull pieces here and there and finish the puzzle.
Being on a special team requires extra training, extra thinking, and extra expectations. It is a unique position with unique arrangement.
Another thing that's kind of drawn me to the all hazard side and the special teams side is that there's not necessarily a hierarchy that we see in the rest of the fire service. Of course, we still have the ICS system and all that kind of stuff, but when we show up to a scene, my hosman might be way better at trench rescue than I am, and he might be who I make rescue group, and because he's in charge of that, right? And so there's no necessarily hierarchy on a rescue scene.
In one memorable incident, a man was caught in a telescoping radial stacker, basically a large mobile conveyor belt designed to move heavy materials like gravel.
He was caught in between the top telescoping section and the bottom, with his legs were. Crushed down on him, covered him with 3-4 yards of dirt on top of that, and twisted him all up inside of this confined space for all intents and purposes, because that's what it was. When we got on scene, he was having a really hard time breathing because his upper body was crushed, his arm was wrapped around a member, and he was turned sideways and kind of crushed over, and then had all that dirt on him. It was such a small confined space that only one of us got in there, and so I climbed in and started to move some of the dirt. Had my guys hand in a cutting torch, an oxyacetylene torch, and I cut that member out that his arm was wrapped around. So I untangled him and was able to turn him back kind of flat. He started breathing much better. Started digging him out and realized that he was caught in between big structural members of this extender. So we had multiple problems. All the dirt on top of him, the gauge of metal that we were dealing with, they were too big to get in. The little angle grinders we had were great, but they weren't strong enough to get through some of the thicker metal. Long story short, 2 hours into this rescue, I knew we had to change gears, and that's hard. We're used to, as firefighters, we get on scene and we quickly make a difference. Even a really bad structure fire, we have it within an hour. Even if we've gone defensive, it's usually a pretty quick turnover. We make a difference quickly. This one, we're 2 hours in, and every plan we were trying was not working, and I was getting beyond worried for this guy. He was in there with me, and he was conscious the whole time, and talking to me. Extremely tough guy. We couldn't give him pain meds because his blood pressure was so low, but he was there, even helping give suggestions and stuff. And I remember about the 2 hour mark, I climbed out and met with IC, the BC there, and I said, we've got to think about this differently. We've got to come at this a different angle. I was like, we might need to get some surgeons in here and do field amputation. What we're doing is not working, and it's taking a long time.
That's not an easy thing to do, to stop and try to look at a situation differently, to weigh what options are available, especially in a life or death moment when seconds can be the difference in survival. But that's exactly what Matthews did.
We were able to use the workers on site. We used their knowledge. They're the experts on that kind of stuff. So we started running things by them, and we asked, if we do this, what will happen? And what will happen if we do this? And they were able to, with our help, lower the front end of that telescoping boom down, which brought up the rear end of it. And once it was off the ground, we realized that there was a 6-inch by 6 foot by 6 foot steel plate on the bottom of this thing. And that plate is what was holding all that dirt on top of him, which was keeping us from seeing exactly where he was, caught. So we were able to use their torch on scene. They had a big truck mounted oxyacetylene torch, and we used it to cut this steel plate off the bottom. And once it fell, all the dirt inside fell, and we could see just how badly he was caught.
In the end, the team removed him from the machine without performing a field amputation, which would have been high risk. Later, the man lost one leg at the knee and another at the hip, but he survived. After hours of problem solving, the tech team relied on the knowledge and tools of the workers on site, a perfect example of the team's ability to improvise and adapt. Looking to the future of technical rescue, we have to consider the rapid construction in the Treasure Valley, which means more trench and confined space rescues, as well as structural collapses. Changes in our environment brings more fires, floods, and mudslides. And with more people comes more emergencies. Let's hear a final thought from Mike Walker.
As a fire service, we are considered all the hazards. So when people call out 911, they're going to expect us to show up and do the job. And for us, we can't afford to just assume that we can do it and solve it when we show up. That's why we have to have a specialized team, a team of people that can dedicate extra time to this particular discipline. And it takes a phenomenal amount of time and training, equipment, and funding to be successful. So that is something in my role that I feel like I have to do is advocate for this team, because if we lose that advocacy and we're not getting the time to train and the equipment we need and the funds, then we're not going to be able to provide the service that people expect.
That's all we got for today. Thank you for listening to the Mission Strong podcast. We'll see you next time.